like this through the microphone?
Yeah.
No,
Yeah.
it's better, right? I probably need a couple of more minutes to check. Yeah. I just have a bit weird resolution here, so I need to probably adapt the size. Can you read this text now? Yeah. Let's go through it quickly. Some of the code examples, and it should still hit the screen mostly. Okay. It's still readable, right? Okay. And I guess we can start. I'm not sure if they are waiting for syncing with the other room. But yeah, it's really nice. Diego unfortunately left, but it's really nice that it's not me who talks about Rex. I usually he talks about it, but it seems like others started to do it instead of me. And today I would like to talk about monitoring Elasticsearch with Perl, and like my story or my company's story with in that topic. And any questions? Because I have some to start with. Who of you uses Elasticsearch? Okay, that's nice. And what data size you have, like total index size? You have any idea about that? Who indexes more than 1 gigabyte, for example? And 1 terabyte, more than 1 terabyte? Okay. So, petabyte, anyone? So, yeah, okay, so there are at least one bigger installation in the audience. Very nice. And if you use Elasticsearch, you most probably also know what Kibana is, right? Which is basically the visualization front end for Elasticsearch. So you can do nice graphs and queries and analytics with it. And who uses or knows Graphite? Okay, nice. And Grafana, have you heard about that? Okay, it's really nice. So yeah, what Elasticsearch is, it's a different slide. It's not a resource exhaustor, but a distributed Lucene, right? Just to have a quick recap for people who don't know all of those projects, which means you can index documents with it, and then can query it. You can run searches against those indexed data sets, and you can have your answers, so you can explore your data efficiently. Also, Graphite is actually 3 projects. It's a combination of 3 projects. One of those is Carbon, which is the caching and the persistence layer. So you talk to Carbon, send data to it, and it handles data storage for you through Whisper, which is a fixed size round-robin style database. So you know your data size in advance. And Graphite itself is Graphite Web, which is the web front end, the real-time graphing front end for all those tools. And Grafana is basically a combination, or started as a combination of Graphite and Kibana. It's a Kibana styled front end for Graphite originally, but it evolved a lot in the past couple of years. So it's basically a generic, more generic front end for different, usually metric data stores. And I'd like to show you first how we use Elasticsearch at our company at Adjust. And we almost exclusively use it for log analytics. We store our internal services logs. We send it to Elasticsearch through Redis, and Logstash helps to convey the logs from Redis to Elasticsearch, and then our colleagues use it for various purposes. We are querying a huge data set, and since it's a logging system for us, our use case is really a write heavy and append only use case compared to, for example, I don't know, the usual search approach, right? And we maybe query the data as well later. So it's really, point is, it's a write heavy use case. And to put the scale into perspective a bit, at peak times, we can have up to 250,000 requests per second on our servers. Each of those requests generating one or more log messages, and we store each of them. So it's daily, it can be up to 15 billion documents, and totaling more than 1 petabyte of data now. It's 1.1 ideally, but I stopped counting about it. Like, I don't look at it that much, like what's the total size. And in order to serve all those mostly indexing requests, right, we have roughly 300 nodes working on it. So this, I think this really shows the distributed nature of this whole setup. Like a lot of machines need to work together to provide that service. And we have a tiered storage solution. We have 40 machines acting as archivers, so long-term storage. Each of them are running 5 data nodes of Elasticsearch. And but we are doing the indexing on dedicated machines, which has a bit different setup. So they have much more RAM and much more CPU power to do the initial index calculation. And then we move it to long-term storage. Plus, we have dedicated master machines, and indexers and master machines have client nodes as well on them. So we talk to the client nodes directly. So we don't talk to the other nodes because they are busy with their own stuff. And we have write client nodes and read client nodes. And all these nodes are exposing lots of metrics. I just asked the cluster with the curl and exported the answers to plain JSON files, like pretty printed it. And then I calculated like how many metrics they contain. If I ask the cluster about how are you, what's your metrics? And I asked for cluster has and stats, also indices stats, plus node stats and node info. And like it's a total of 320,000 different metrics that I can ask the cluster, like with these 300 nodes, right? Because for example, node stats has details information for each node, right? I don't know, 100 metrics for each node, or at least that. So monitoring this much metric, especially efficiently, so you want to do it fast, and you don't want the cluster to spend too much time on answering all the monitoring queries. That can be challenging. And we started with a much smaller cluster. Of course, 2 years ago, it was like, I don't know, only 6 machines total, or maybe less. So we used our usual monitoring approach. We use Zabbix for that. So we started collecting the most generic and the most important metrics that we were interested in. What's the cluster status? Does it feel well as a whole or not? Or remaining disk space, right? To ensure that we can still store data, or when we should add more machines. Also the JVM heap usage, because if it goes up, then that's usually a bad thing for the cluster, or at least for that node, but it can be a bad thing for the whole cluster, especially if it happens on a master node, right? And but that doesn't scale well, right? So we looked into other solutions, like how we can do it better than we actually did at the time. And the usual answer for that is just use Marvel. That's the upstream's solution for this. It's actually an Elasticsearch plugin, right? You just install it for all the nodes you want to monitor, and it sends those metrics into Elasticsearch itself, actually. By default, it monitors the same cluster where it stores, but it makes sense to just build a separate monitoring cluster where you store all raw metrics, because if you have problems with your production cluster, you want to still see those metrics, right? But that's the official one, and it's really nice. As I said, it collects metrics in Elasticsearch. it also has a Kibana-like interface. Actually, it was fully integrated into Kibana with time. So it's just a Kibana plugin, so you can use the same UI for interacting with that. But it needs a license. And they opened it up recently. So the very basic usage, like with Elasticsearch 2, they opened it up. Basic usage is free. You get some metrics, but it was for us basically this set of metrics that we could get for free was basically the same that we already had. So it was not really added value for us. We played with it, but you still need to register for license for that as well and stuff. So we asked for okay, we probably need much more from Marvel than the basic edition can do. We would be probably willing to pay if it has a reasonable price, but it turned out that it's just too expensive for what we wanted to do with it, because it was like almost €1,000 per node per year, what we got, and it's just with our size, it's just too much, right? I mean, I can go to a team lead or CTO and finance that, I would like to spend tens of thousands or hundreds of thousands of euros just for monitoring. So we had to look into other solutions and started to think that we already have Graphite, we already have lots of metrics pushed into Graphite from various systems, and we already had Grafana as well. So basically the UI could be the same if you somehow could push data to Graphite from Elasticsearch, and probably somebody already did that. So I started Googling, I found a really nice project first. It's called ES2 Graphite. It does what the label says, sends Elasticsearch metrics to Graphite, and there's the GitHub link for that. I believe it's a Python project, but it was really slow to execute when I tried it out first. And it's like I looked at the code, like what it does, maybe I misuse it or stuff, but it actually sends multiple requests for a lot of various subsections of the whole metric picture. So it was asking the cluster a lot more than I expected. So okay, that in itself shouldn't be a big problem, but it was also post-processing basically each of the metrics afterwards. It got like it did some normalization of names, and sometimes it filtered out something later or converted stuff around. So most probably because of that, it was not really efficient for us, because I think I had to just Control-C the process after, I don't know, 5 or 10 minutes, because it's like, I mean, I even want to ask the cluster every 10 seconds for metrics, not like every half an hour, right? So I thought that, yeah, let's go to Cpan and see like if somebody already did in the Perl space, right? And there's this App Elasticsearch utilities distribution, which is a really handy collection of various Elasticsearch utilities to monitor and to interact with the cluster via Perl scripts and Perl modules. And they have this ES static and ES dynamic Perl scripts. The difference is the static always returns the same metric names, even if the Elasticsearch upstream changes their name between releases. So it tries to keep monitoring static. The dynamic one is like just exposes them as they are. So they're roughly doing the same. But because of that, like for example, especially the static one, still has to convert a lot of metrics, and especially with time, when more and more changes are accumulating. It was still slow. It was much better because, I don't know, in 2 or 3 minutes, I could get every metric I wanted to monitor. It's like, okay, we can optimize this. But we started to think that, oh, we can make it really efficient. Like I expected like some seconds, right? In that range, like it should be fast, because we already know that Elasticsearch gives us metrics in plain JSON. I just asked it via the HTTP API to get a JSON response, and that's usually very fast to get that. And something like this. right? This is the cluster has JSON reply. You have very top level metrics here. It's just an overview, but it's already very handy to have and to know about those. And there's a Search Elasticsearch module, which is the official Perl module to interact with the Elasticsearch clusters. And of course, since it's from upstream, it supports all of the Elasticsearch APIs, right? So including cluster has, cluster stats, node stats, all the metric-related APIs that we were interested in. Also, Graphite, on the other hand, has a very simple input format, which is basically space-separated metric pass, including with the name. Then you provide the value and then a timestamp, and that's it. So that's very easy to send over the network. Like something like this with a real example. And also, since it's just plain JSON, it's very easy to read into href, right, in Perl. And then Graphite format is basically just a flattened hash, because if there are multiple levels in JSON, if you flatten it, you get, especially if you use hash flatten, you get a dot separated data structure with the value afterward. So it's very easy to convert. Usually it's very fast. Like I didn't have problem with this speed yet. And the last piece of the puzzle is that we need to talk to Graphite actually. And for that, we found NetGraphite. So it seemed like after half an hour of Googling that maybe all of the components are already in place. They are not perfect, but it's like, it didn't seem that hard to do some experiments at least, right? To see that, yeah, let's see if we can do faster than the project. And also part of the idea was to filter out metrics that I'm not interested in as soon as possible, instead of just almost at the last step before sending to Graphite. So if possible, don't even ask the cluster for metrics that you don't want to monitor. For example, I don't know, file system related stuff, like what's the data path for the node, because I don't want to monitor that. And I started coding, and I just used all of those modules in a Perl script. The answer, somebody asked, like, what do you put into the sheet in the Perl scripts? Maybe that's an answer, but like that was not my point here. And I added some tracing and enabled some testing in the NetGraphite module, because I did not want to send it there yet. Just print it out, please. I defined some status mapping, like the green status is 0, yellow is 1, blah, 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 because I don't want to send it as string later to Graphite. I just created a new object to talk to Elasticsearch. Did the same with Graphite. I want to talk to Graphite, right? Trace mode. And then I started to actually query the cluster, right? Okay, give me the cluster health, put a timestamp on it, because there's no timestamp in the response, and I need to send it to Graphite. And just send it to Graphite later. That here's my data, that's what returned, that's JSON, and I need to do some transformations on that, because it's still JSON, but I need to flatten it first and stuff. And you can pass a subroutine reference for that, and that's how it looked like. Like, just get the timestamp, the cluster name from the JSON data that I just got from the cluster, and specify the Graphite metric path that I want to use, and convert the status, flatten the data, and like just create a big string that we can send toward Graphite, right? Because that's what the expected output from the NetGraphite module. And it worked really well. It was so simple. We continued looking into for the other APIs, like cluster stuff. Basically the same, we just changed the name, right? So that's why it's the naive approach. It's just, we just kept coding without anything else, just a proof of concept. And I have a bit more complicated transformer subroutine for cluster stat, because I have to filter out much more metrics that I'm not interested in, but it's still part of the reply. And I believe, unfortunately, for the cluster stats, I couldn't not ask the cluster for them. So I was always getting those info, but I did not want to monitor. For example, what operating system it runs on. I don't want to store that as a metric. And then there was some small workaround for calculating the number of client nodes, just for the sake of completeness. I believe it was fixed in the recently released 5th main version of Elasticsearch. And then, that's a bit too big slide. It's basically the same at the end, right? So you probably can see the repetition now. The only difference for node stats, the next metric we were interested in, we can actually ask a subset of the whole story for node stats. So that was the part of the idea I mentioned earlier, that don't even ask the cluster if I'm not going to store it, right? So I can filter a lot of things out before even start to post-process it. But then again, all the post-processing is really the same. It's a filtering step, some workaround or conversion maybe. And at this point, I ran a bigger test, and it returned 52,000 metrics in 2.5 seconds, right? That was something I was looking for at the start of the story. And it's like more than 20K metrics per second to retrieve and transform and send to Graphite. And it felt much better than like this couple of minutes of runtimes earlier. So we found that we can do it faster. And at that point, we decided, yeah, let's propose a talk at the Barcelona workshop, because it might be interesting. And but still some stuff was missing, mainly configuration, right? Probably others use Elasticsearch in much different ways than we do. So probably they are interested in different metrics than us, yeah. And also, there were many applications in the proof of concept code, right? You could really see the repetition. We wanted to do this right. And right now we run this script from a cron job, like every minute we just collect the metrics, push it to Graphite, and that's it. But it would be much nicer probably to run it as a proper daemon, right? It runs in the background and like wakes up every 10 seconds, or configurable schedule to wake up, and then have a more fine-grained monitoring. And also, we felt like probably not everyone uses Graphite to store their metric data, so it would be nice to do some pluggable output system, and instead of forcing Graphite, right? And we basically wanted to have some configuration like this, which is very easy, like it's just YAML, right? So it's easy to write as human as well, and just configure where are my Elasticsearch cluster, where's my Graphite, what prefix I would like to use for the metric names, and what to filter out and what to convert. So this is like for cluster pairs, convert the status, right? For cluster stats, filter out these fields. And so that was like what drove the design later. And I started to refactor original approach. I call it Elasticsearch metrics right now, and that's just the work title. And we just have an Elasticsearch attribute, and we define an API mapping. So if I ask that please act in this specific mode, like in cluster health mode, then you can get the metrics like this. So I can tie together the different modes, retrieval processes with their filtering and conversion configuration. So it's like one code can act differently based on configuration. And that was the main idea, right? And we define some default configuration, and we read from that file. And then we just get it, right? Based on which mode I ask from this object. Then it selects based on the API map we defined earlier, executes the subroutine reference, and then we got a bit different result set based on which mode I asked for. And the only thing at that point we missed was output module, right? So I started coding Elasticsearch metrics output graphite, right, which is intended to be modular there. And this is a similar approach. We can toggle tracing if I want to just output to standard error or actually send to graphite. And I also just have a graphite attribute, and I have a send method currently, which just asks for the whole set of data according to the actual mode we asked for, and then sends it to graphite after transforming it, right? So there should be a transformer, which again was a lot of repetitive code, right? Because we usually just get the data, extracted the timestamp and the cluster, we define some prefix, which is much more dynamical now. And we started some filtering, conversion, flattened and output it, right? And I believe most of the work is done. It's not completely finished yet, unfortunately, but this way we could define behavior in a bit nicer way, and also can drive it by configuration, right? So other people can use it very differently. And I mean, this is the actual state of this project right now. We have future ideas about it. Most importantly, it would be nice to open source it, which I essentially just did by showing most of the code, right? So there won't be any problem with that. And maybe it would be nice to even put it on cpan, right? Because that's the way the things we like. And for that, it would probably be a good idea to merge it into Elasticsearch utilities, right? Because I don't see much point starting yet another module just for monitoring. So I would like to contact the author and see if we can somehow integrate it there. But I don't know, the approach used is quite different, but I think that would be the ideal, right? And also we have some other in-house project. One is Elastex, which is like retrieving or dumping data actually from a Elasticsearch cluster in a efficient way using the scan and scroll technique, which is yet another utility which might go into the same module, right? We also have some ideas about the command line Elasticsearch dashboard with a similar approach. And since we just retrieve metrics in a library in a configurable way, instead of putting it to graphite, maybe we can just have a CLI output, right? So to have an overview of the cluster from the command line, which I believe does not really exist yet because everyone uses Kubernetes as a front end. And also, Graphite supports the Pickle protocol, which is Python's own serialization format, but I believe none of the Perl modules interacting with Graphite supports it. Most probably because nobody wanted to re-implement it in Perl, right? But this would enable, so what it would be interesting, why it would be interesting, it's like with the Pickle protocol, you can send many metrics to Graphite in a single request. So instead of 50,000 requests, please store all these metrics one by one. You can just send it in one step. That would probably improve performance more. So that could be another project to look into, like how to do it, probably with inline Python or something like that, but I didn't do much experiments yet with that. And actually, that's where the story is today. Hopefully, you can try it out very soon. Probably we will just push it to GitHub when I get the permission for that. And do you have any questions about this approach? How do you monitor? but we can talk about that later if you don't want to talk. Yeah, okay, thank you. Sorry?
No, that's fine.
Thank you. I'm not sure how much time I took. I didn't check the clock when I started. That's okay?